when I'm like, ah, shut up, and then I'm saying that on the video. So I know you can, and then I always cuss, right? It's Will, right? Or Alex, Will. You. Oh no, you're neither one of those people. You're like, I am neither one of those people. Because that is not the right process. There we go. There we go. And Ethan, you frightened everyone away. Yay for you. So everyone has left you. They've left you. Okay, you're back. Caitlin's gone. Vegas is gone. That whole row, Samantha, girls are right here. Daniel Avonlea. Avonlea, oh, I love that. I got you, baby. I'm just doing roll real quick. I am just doing roll really quickly here. Sorry. Okay, so you just moved over, yeah? Yeah. Okay, so we're missing, you said Elena never comes? Yeah. No, Rebecca.
There's no three. Just the three goes.
Okay, are you guys ready? Let's take a look at this. Let's see what we got. Okay, so am I taping? Oh, that's awkward. I am taping this whole time. So I split it up lots of ways. I did 8 and 6. That's just kind of what I picked because that's what comes to my mind. I love 24 and 2. I love 16 and 3. But I would never. Here's the reality. If you were doing it the way your 7th grade teacher taught you, you should be using 16 and 3. But no one ever thinks of 16 and 3 going in there. I don't think of it. So I would have done 8 and 6. Right? I'm going to keep going. The 6 is going to be 2 and 3. I'm going to put some boxes around there because I wrap those up. And that is going to be 2. That's a dead end. And 4, not a dead end. And 2 and 2. So there we go. I've been looking for my friends to come out. So remember, it takes 2 to escape. 1 dies in the process. So here we go. 2 come out. 1 dies in the process. It's going to hook up with that 7. Oh, look, I got another 2 over here. Gonna come out. 1 dies in the process. So I got another 2 out there. That little 3 is left inside. So I'm gonna go 2 times -7, which is gonna be -28 on the outside and 3 on the inside. Could you do me a favor and wiggle your fingers if you're okay with that? Right on, right on, right on. Are we good? Okay, so here we go. We've got new stuff for today. Well, it's not really new. You've seen it before, but it's been a hot minute, so I have notes for you. Do you see it on your little paper? Everyone good? There was something that we didn't do yesterday. We're going to do that, and then we're going to do some new geometry at the same time. 2 lessons in 1. How delicious for us. So what we're doing is a thing called rationalizing the denominator. And here's what you're going to write down on here. You are not allowed to have jail. And jail, what I mean is by square root, right? No jail in the basement. Give it a twin. This is the Mrs. Tarantino way to do this. You've actually learned how to do this. You all know how to do this, but I'm just going to walk you through reminding you how to do this, right? So here's the problem. We're going to get problems that look like this. 5 over root 2. And we are not allowed to have a jail cell in the denominator. It's not allowed. So what we're going to do is we're going to give this guy a twin. We're literally going to randomly put some guy in jail with him so he can escape. But the rule in math is balance. What we do to the basement, we have to do to the first floor, right? So I have some examples to do. You're going to write them right here, 1, 2, and 3. I used a whole screen for it. Are you guys okay with me? So here we go, rock and rollers. Here's our first one. You're going to write this under number 1, right? So here's the problem. We are not allowed to have this. Let me tell you why. because root 3, if you do it as a decimal, it goes on forever. It never stops. And we can't divide by something that goes on forever. So the way we rationalize a denominator is to give it a twin, meaning we want this root 3 to escape. So we're going to give him another root 3 because that's going to allow him to twin up and escape from jail. But we can't just randomly throw that on there. What we do to the bottom, we have to do to the top, right? Because root 3 over root 3 is 1. That we're allowed to do, right? So let's see what happens when we clean this up. These guys escape from jail. They don't cancel. They get free. We circle them. 1 dies in the process. It doesn't become 9. It doesn't go away. It just is freed from jail. And the rule on the top is this, and this is real life. People on the outside multiply with people on the outside, and people on the inside of jail multiply with people on the inside. So what we're really going to do now, we're going to pretend there's a little 1 right there. The 1 and the 7 go together, and the root 3 comes along for the ride. And that is that guy rationalized. Is it hard? It's not. I believe you've actually seen it in Algebra 1. It's just been a hot minute. Is that cool? Are you feeling it? Okay, we're going to try a couple more, and then we're going to go to the real lesson for today. And then I'm going to shut up and check off homework, and yay. Okay, so, that was we've already done one then. How about number 2? Here we go. So, there's 2 ways to do this one. There is the easy way, and there is the right I just taught you. So if we wanted to do it the way I just taught you, we could. But I want you to be smarter than that and recognize that sometimes it's a trick situation. And here's the trick situation. I have an inside guy and another inside guy. They can reduce each other. Is everybody cool with that? Can I do this on this guy? No. He's inside, he's outside. I can't reduce them. But these guys, I can. So 2 goes into 2 1 time, and 2 goes into 6 3 times. Does that make sense? And guess what? We all know the square root of 1. What times what will give you 1? 1. So when you have that, guess what? You get just square root of 3 over 1. Or, for some of you smarty pantsies out there, just the square root of 3. Are we cool with that? Can you do that all the time? No, but I want you to watch for it because you guys are smart, right? Now, if you had done it the other way, would it have worked? Yes. It just would have taken us a lot more steps to do. And I'm trying to save you some work here. So I would like you to take a look at, I don't know why I put, we're going to do 2 problems. We're going to start with this one, and then we're going to do that one. And here we go. So this is under 3. I think we have room for 2, but if you don't have room and you want to do this one on your desk in a minute, but let's not start with him. Let's put him out of the way. Let's start with this guy. Okay, so first thing is, can I reduce it? 2 and 5 don't go into each other, so I can't reduce it. So the next thing I'm going to do is I'm going to rationalize it. I'm going to give it to the bottom and to the top. Ethan's watching me. We're writing this down. Okay, so here we go. Square root of 5 to this guy. Square root of 5 to this guy. Inside guy come together. So here's what I got. This becomes a set of twins, and it goes away. So it just becomes 5 comes out. 1 dies in the process. And on the top, what I'm going to get, this is tricky. Inside guys multiply with inside guys. Outside guys multiply with outside guys. So if we pretended there's a 1 here, the 1 and the 3 multiply, and the 2 and the 5 multiply. Now, here's what every kid in the world wants to do. They want to reduce those, but we can't, because inside guys multiply and divide with inside guys, outside guys with outside guys. So those 2 guys are done. Are you cool with that? Okay, this next one's tricky. I'd like you to try it on your own. It's tricky. Let's see how you do. Let me bring him back up.
Somebody has a question.
I have an answer. You get that? You did it already?
Yeah.
Okay, and then you almost have the right answer. So you're going to see in a second. See if you can look at it now. Do you see it? Yeah, you almost did. So go ahead and try this one. This one right here. Sorry. Let's get this guy out of the way. Move over here. Try that one. Yes. Yes. Why can you? Can you tell me? Outside guy. Right. Very nice. Very nice. Very nice. It is the square root of 6. Do you see why? Because those outside guys just went away. Love this. Love this. Are you good on them? You good? You guys good? Yeah. Okay. Love that, ladies. Thank you. Are we good? Okay, that's good. Okay, let's take a look at it. So here's what I'm doing. First thing I always check for, can I do any canceling? I can't. I love when I can, but I take a second and check. If I can't, I got to rationalize, which means I give him a twin, and what I do to the bottom, I do to the top. So everything's looking good. Remember what this means? It frees this guy. One dies in the process, one gets free. So it's looking pretty good. Now, inside guys with inside guys, outside guys with outside guys. So 3 root 6. That's a great answer. It would be wrong on a quiz or a test. You get partial credit. What can I do beyond this? I can cancel something. What can I cancel? Those 3s, because they're both outside guys, right? Boom. My answer, root 6. So that's crazy. This whole ugly thing is just root 6. On your table now, go ahead and slide your paper away. I want you to try 1 or 2 other ones. Let's see. I think actually that might be it. I think I'm done with that. Yay, yes. Okay. So I would like you to take a minute before we change gears, and I would like you to turn to your neighbor if you have one, and if you don't, you're going to come talk to me. And I am offering you $15 to go get lunch at some place that's quick food, not necessarily McDonald's. Where am I taking you? Talk amongst yourselves. Decide where I'm taking you. So $15. I'm paying you $15, and I'll go get it. I'll leave and I'll go get it. Where am I getting it? Oh, nice. Oh, yeah. I just realized.
A lot of projects. It's for like English and English. It's like a big class.
Chick-fil-A's not that good. Look at that face you just gave. I just think it's bland. Is it bland?
If I did, yeah.
Yeah, it's kind of
If I did.
Wow.
Nuke the whole generation. I have my thing. Reach it. Pretty please. Where do you go?
Talk about, where am I taking it? You like the sauce, because everything else has is blank. It's under my dog. Fair. Where am I taking it? Talk about, where am I taking it? Where am I taking it? Okay, that's where I would take it. Where am I taking it? Oh, good choice. You got a little bit of a dog. Where am I taking it? Okay, here we go. Here's why we're doing this. So the next 2 days are weird days. So this is back onto your notes. And now we're back to geometry. Honest to God, into full-on geometry. So we learned Pythagorean theorem, but we are going to learn some other ways to find all the parts of a right triangle. So one way is Pythagorean theorem. Then there is another way that we're going to learn next week called trigonometry. It's my favorite thing to teach, like, of all time. But today and tomorrow, we learn that there are these weird 2 triangles that are literally called special right triangles, right? They're these weird two triangles, and they get used a ton in algebra 2, algebra 2 trig, and pre-calculus. Like, we use them so much. So I'm going to show you this, and you're going to think, wow, this is kind of weird, and you're going to trust me when I tell you it's one of those things that next year, if you know this here, you will be ahead of your peers next year who are like, oh, shit, I don't remember that stuff. Okay, so I just cussed. There we go. So first thing I want you to do on your little thing, I want you to draw some parts for me. This is going to be a right angle. This is going to be a 45-degree angle. Well, if he's 45 and that's a right angle, this also is 45 degrees. Are we cool with that? So, real quick for me, the guy across from the right angle, what is he called? He's called a hypotenuse. He is a hypotenuse. Hypotenuse. There we go. Now, here's what's also interesting. Since it's 45, 45, it's isosceles, meaning this side and this side are the same length. And we're going to call these right here legs. This leg and this leg are exactly the same. There are two. There are only two legs, and they're the same. So here's what we're going to do today. I am going to give you one side, one measure. Like, I'm going to give you, this guy is 5 centimeters. And your job tonight is going to be to figure out what this guy is and what this guy is. And I'm going to tell you, there's a quick way of doing it without using the Pythagorean theorem. Are you ready? So here's what I want you to write in the middle. In the middle of your triangle, I want you to write square root of 2. So here's what a weird thing they figured out is that on any 45, 45, 90 triangle, anywhere in the world, anytime, these parts are related by this magical number. And the magical number is the square root of 2. So here's what's crazy. If I was going to do the whole thing by the Pythagorean theorem, and I knew this side was 5, I knew then this side is 5, and watch this. Without doing any work, the hypotenuse is 5 root 2. It happens every time. It's a little bit of gypsy magic, right? So the only trick tonight is to know whether we're going to multiply by the square root of 2 or divide by the square root of 2. So here's what I need you to know today. 2 things. The magic number, and here's what I need you to write down somewhere on your paper. Little too big So here's what's going to happen tonight. If we are going from the little side to a bigger side, you're making it bigger, you're going to times. That makes sense. Times to make it bigger. And if I am going from the big side to the little side, I am going to divide by root 2. Now you see why we did that whole rationalizing the denominator thing. That's all you're doing tonight, is you're going to remember the magical number, and you have to see it to yourself. Do I make it bigger, or do I make it smaller, or is it the same? That's it. It's easy. It's easy. So here we go, lambs. We got it. Here comes our first one and our first little one to try. So the first thing I recommend that we do is that we label our parts, right? The one that matters to me on this one is just the hypotenuse. So can everyone look at their neighbor and, you know, make sure your neighbor's not messing up here. Put your hypotenuse right here. And this is going to be a little L right on here and a little L. How do I know that? Because they're not the hypotenuse, right? And here's what I want to show you real quick. Sorry, I'm going to go back. Look at, I put these all over here. You know, these are all 45 triangles. They're just mixed any old which way. They all work the same. It doesn't matter whether they're sitting nicely or not. I have some kids who don't like it this way. So what I encourage you to do, if this is messing your brain up, is sometimes to move it, watch this, to twist it around so it's like twist your paper so it's laying in a way that you like. You can twist your paper around to do that. So I'm just letting you know that you can, that sometimes I tell kids to do that. Okay, here we go. So here we go. We're ready to start. Watch how easy it is. We're starting with a little leg. So let's get his other little leg. What is X going to be? 8. So easy because they're the same. Oh, light work. What is the hypotenuse going to be? I'm going from little to big. I'm going to multiply by root 2. 8 root 2. Here's why. Outside guy with outside guy, inside guy with inside guy. Does that make sense? So we just tack him on. So think of that like a 1 root 2. So the 8 and the 1 multiply. The root 2 just comes along for the ride. Does that make sense? Look, you just did one. That's how easy they are. Let's try another one. Okay. Can you please do this one all by yourselves? And if you're like, Miss T, come on, light work. Yes, that's my gift to you. I have literal no idea what time we're after. I'm going to close this. 11:21, okay.
What?
I've been teaching 0, 1, 2 for like 8 years. So, okay, here we go. Here's what I did. I always start like this. I put my hypotenuse here. I put leg here, leg here. I always start with the leg in matching. So if that's 25, that has to be 25. Yay. And now I say to myself, am I making it bigger or am I making it smaller? I am making it bigger because I'm going to the hypotenuse. So the magical number, if that helps, 1 root 2, I'm going to times 25 by 1. So 25 root 2. Obviously, the trickier ones are when we have to divide and go backwards. So let's try some. You ready? Are we okay? Everyone okay? No one's like, Miss T, I have no idea what you're doing. Okay, so here we go. Are you ready? We are now going to go ahead and label our parts. Let's start right here. That's our hypotenuse, which is our big guy. We need this guy and we need this guy, and they're going to be the same. So whatever I get for X, I'm going to get for Y. But in this guy, I'm taking a big guy and I'm making him smaller. So instead of multiplying by root 2, I am dividing by root 2. Here's what it would look like. 19 divided by root 2. Uh-oh, what's wrong with that? We can't have root 2 in the denominator. Gentlemen, so here we go. We're going to rationalize the denominator. That's why we did all that weird stuff that we've been doing for the last couple days. So on this one, I'm going to get 19 root 2 over, be careful, 1 dies, 1 gets freed. There you go. That's a crazy looking answer, but that's okay. We're going to leave it just like that. And what I get for the other one, 19 root 2 over 2, I'm going to make sure I can't reduce the outside guys, and I can't, so that's all it is. So is it weird looking? Yeah. Is it hard? No. Right? I think I have 2 more for desk work. So if you erase everything that's on your desk, I got 2 more for you to try for desk work. Okay, can you try this one? Ladies, here we go. Try this one on your desk by yourself, on your desk. Now, if you want to draw it, that's awesome. If you can just kind of see it, that's cool too. I love the way you do that. You know what's easiest for me? So then this is right here, that's perfect. 3 root 3. Love that. Awesome. Yeah. So we're going to do that was easy, right? Because they're the same. But now we're going to make them bigger. So
I know, oh my god.
as soon as you multiply it on the inside, guys, go by and that's your y. How about your
Root 6 because so basically you multiply 3 root 3 times root 2 and you just
This is what I need you to guess. I know how to do this. Right, that's fine.
to get x.
It's going to be the same.
So no, y is 3 root.
Is it the same?
I got that.
And then x.
Times by
And
root
then
2.
x is whatever the times
Is
are.
that
times
times 2?
That's
Root 2. And inside guy goes with inside guy. So root 2 is our magic number.
So 6.
Root 6. Yes, yes,
Three root
yes,
six.
yes. So I see almost everyone got this, right? 3 root 3, yay. Now I am going to make this guy bigger. He's going bigger. So I'm timesing by root 2. And the rule is what we just did tonight. Inside guy with inside guy, outside guy with outside guy. These are 2 inside guys. So the answer will be 3 root 6. That easy. That easy. Let's see what I got going on here. Was that, oh, I do like that one. Sorry it's so messy. Let me just, oh yeah, okay. And I think we're gonna stop after this. Maybe, yeah. This one is a trick problem. Love this problem. Love this problem. Love this problem. We're doing this next. Oh. Not that, yeah, because we're making it bigger. We're multiplying magic number root 2. Almost done.
Oh no, it's 3 4.
5. So you walk further. Can you tell how you got that?
Yeah.
Yeah.
Oh, what is this one? Can you fill it up? Nice. Love that for you. This is not my problem. This one. You are not quite done yet. So make that into 3 root 4. Or tell yourself, look, I have twins right there. So one dies, one gets free. Does that make sense? No, because that you kept them in jail.
Oh, and then you
Yes, there you go. Love the way you did that all the way through. So nice. Yay. 3 root 2, almost everyone got. A little bit of trick on this one. I'm going to make it bigger by multiplying by root 2. So let me tell you, there was 2 ways to do this one. I'm going to multiply by root 2. You could go ahead and multiply those together, inside guys with inside guys, and get root 4. Just remember, check to see if it can be broken up. 2 and 2, look at that. The 2 dies, 1 comes out, I get 6. But some of you see that right here, look, those are twins as well. So I don't even have to multiply them right away. 1 dies, 1 escapes, so I'm still at 6. So the last thing I want to show you is this. So I'm going to be really honest. I have 3 levels of kids that I need to get through this class. I have kids who are just going to take financial algebra. They're like, Miss T, just let me get through my pass and be done with high school. I have kids who are going to algebra 2, right? And they, you know what, they're solid students. But I have some of you who are writing down, I want algebra 2 trig. And for you, I'm going to need to push you and challenge you a little bit more because algebra 2 trig is no joke, right? So I have one more problem. I am not going to do it, but I am going to leave it up for kids who want to try it. If you think you are going to algebra 2 trig, This is the kind of problem that you're going to need to do. Watch what you're going to need to do. You're going to need to go from this guy to this guy, and then from this guy to this guy. If you want to give that a try, but if you were one of my friends who wrote Algebra 2 Trig, this is the kind of thing that you should be able to get yourself through. That we're going to divide, and then we're going to divide again. If you are thinking, Miss T, I don't need that gypsy magic, that's cool too, right? Okay, so here comes your homework. And for those who are watching at home and who've been absent, goodbye, goodbye.